let's go with the slide. Here we are. And I think this is where we left off before. Oh, let's get it. Slideshow set up. Chrome cross. And you can't see anything yet. Black screen. Like I said, everything is real slow today. I don't know why. All right. Even though that might look good to you, what's on my screen is not what I want to record because it's too small. So I have to change it to that. Okay. Looks the same to you, I'm sure. But okay. Looks like our projector's not too bad a shape, so we'll go from there. All right. Any questions on what we've done up till now? All right. Where we left off last time, remember the last slide said, this was something, the previous thing, then it says, a function defined by two or more equations over a specified domain is called a piecewise defined function. That should have been on the slide with this, but I guess they didn't want to waste the slide, so they put it on the bottom there. Here is an example of a piecewise defined function. Alpha of x is defined one way for negative x's, another way for x's greater than or equal to 0. So one function has two equations that define it over different parts of the domain. What's the domain of this function? All real numbers, because it goes from negative infinity up to 0 for this part, and then from 0 on to positive infinity for the other part. So the domain is all real numbers, but the domain is split into two pieces. Doesn't have to be 2, it could be 3, 15, whatever, you know. And usually you account for all the x's, but you really don't have to. But whatever your x's in your domain. So there's your piecewise defined function. What it says, evaluate this function when x is equal to -1. How in the world do you do that? Plug in what? There's two equations there. Say again? Okay, only the one that pertains. You figure out where Waldo is. Okay, here's your -1. Where is Waldo? Where is -1? It's in the first equation. So we don't use this one. There's no reason to, because this is not in that part of the domain. So we only use the first part. And what would that be? It would be -1. Whoops, forgot to do this. All these steps you have to go through. Okay. It would be -1. We're going to use the first one because -1 is less than 0. So it would be -1 squared plus 1. What's -1 squared? 1 plus 1 is 2. Didn't know you'd be doing such high-level math today when you came in, did you? 1 plus 1 is 2. Okay. So there's evaluated x equal -1. How about x equals 0? You use the second equation because this is less than 0. This includes 0. The equal is there. So what would it be there? And by the way, how we write this is f of -1. F of 0 is 0 minus 1. We use the second one here because that's where the 0 is. Okay? And that would be what? -1. Perfect. And then how about 1? Where's that one? Second one again. So f of 1 would be 1 minus 1, which is 0. All right, we did it. Not too hard either, was it? Okay? Now, one of the first things I heard, you evaluate them both. No, don't. Don't waste your time. I'm looking for one answer. Where is f of 1? -1, 0, 1. Whatever that is, use the one that pertains. Okay? Now, I'm going to erase all the ink on the slides. And, oops, that's not what I want to do. And here's their solution. Okay, the two parts. Because x equals -1 is less than 0, we use the first equation to evaluate f of -1. -1 squared plus 1, that would be -1 squared is 1, plus 1 is 2. All right. Okay. It's Diamond, all right? Okay. Know you're in here, hiding. Okay. There you are. Okay. Anyone else come in since the called roll? Okay. Any questions on that? Then when we're evaluating x equals 0, we use the second one because that's where your x is there. That part of the domain is what we're using, so therefore we use this equation. Okay? And that will be 0 minus 1 is, of course, negative 1, just like I got before. And then the final one is x equal 1. That will be in the second part 2. So that would be 1 minus 1, which is, as we determined, 0. Okay. No questions? Or any questions? All right. That was example 4. All right. They're skipping example 5, example 6, and going on to the domain of a function. And it's a little bit of a mystery to me why they would choose to do so, because to me these are two of the more important problems, and they're going to show up in your homework. And, you know, I wouldn't even be surprised if they'll show up on a quiz or a test, okay? So let's do those as well, unless y'all just don't want to, right? Okay. Let's do, oh, this is so bizarre what we have to do here. I go to a white screen, and it's the next part. Let me get your name, please. I can't hear. Brooke? Brooks. Is that your last name? Okay, yeah. Jermichael. Right? Okay, got it. Okay. I'm hard of hearing. Sorry. Okay. Now, finding the values for which f of x equals 0. Find all real numbers x. I'm going to write this down because not all of you have books yet. Please get your books if you can. You don't have to have them, but they're certainly useful, okay? But it can be ebook, it can be anything, but, you know, take pictures of them, whatever. Find all real values x such that, and that vertical line usually means such that, f of x is equal to 0. Okay? Now we know something about f of x. We want to find out what x is makes that true. The a part here is when f of x is equal to negative 2x plus 10. There is your function. Okay? Now we want to find the values of x that makes that equal to 0. So what might we do first? Set it equal to, no, not plug in 0. That's when x is equal to 0. You know why x is then, that's 0. This says when f of x is 0. Well, there's f of x right here. This is f of x right there. So what do? We set that equal to 0. That's what it says, doesn't it? F of x equals 0. F of x equals 0. Well, this is your f of x. Now, what can we do with that to find the x? That's what we're looking for. Say again? I can't hear. Okay, you want to isolate the x. Get it by itself. Just have a naked x up there and see what is on the other side. So what do? How do we isolate the x? Subtract 10 from both sides. Ooh. Okay. And then, what do you have? Negative 2x. This adds to 0 is equal to negative 10. And then what? Divide both sides by negative 2. And that gives you x equal 5. Okay? Find all the values of x, which makes that equal to 0. Let's see if we did right. Okay? Here's your f of x. You plug in a 5. Negative 2 times 5 is negative 10 plus 10 is 0. Sure enough, that did it. And there was only one. A little hint here. Does anyone know what kind of an equation you call this?
Two-step.
A what?
Two-step equation.
Two-step? Okay, yeah, that's what like a dance is. No, what did you call it?
Two-step equation.
Okay, yeah, that's one thing to do because we took 2 steps to answer it. But I'm talking about in terms of the exponent here. What's the exponent of this variable? 1. What kind of equation always has only exponent for the variable is 1? A linear equation, exactly, okay? I wasn't being Usain Bolt, but yeah, that was a linear equation. Anytime the exponent, the only exponent you have in the equation is 1. That makes a linear equation. When you have a linear equation, exponent 1, that means generally you'll have one solution. You may have no solutions if it's really weird, okay? But usually you'll have no more than one solution, okay? Hang on to that thought for later, okay? Now, the B part here, I hope I have room for it, okay, is f of x is equal to x squared minus 5x, that's a pretty ugly x, plus 6, okay, there's your f of x. And we want to find all the x's such that that f of x is 0. So what would be the first thing we do? Set it equal to 0. Sounds like a capital idea, okay? Now, how do you go about solving, and what kind of equation is this? The maximum exponent is 2. We have a name for that kind. Is it a what? It doesn't sound like 2, it sounds like 4, but it really means 2. Quadratic equation, very good, okay? It's called a quadratic equation. Now, what's the typical? Now, you see when you have a linear equation, isolate the x, solve for x. When you have a quadratic equation, you have an x squared here, x there. It's going to be sort of hard to isolate the x. So what's our technique? Factor, okay. Now, I have this dumb question that I ask people sometimes. If you are having trouble coming up, he came up with the thing fine. When I ask the question, what is the F word? What was it? Factor. It better be factor in this course. I don't know where your dirty minds are going, but in this course, when I ask what's the F word, it's factor, okay? So we're going to factor. If we can factor it. We don't know for sure. Can we? Well, let's see if we can. And by the way, this is the kind of stuff that's in those first 3 sections. We weren't going to take the whole time to do them, but we can do them now. How would you go about factoring that? Say again? Oh, boy, y'all are really quick, aren't you? Okay. Let me go through the technique, okay? You're absolutely right. What I do is what I call unfoiling. I've never seen a book quite call it that, but I unfoil, okay? You know what I mean by that? Foiling when you multiply 2 binomials, first, outer, inner, last, okay? Well, unfoiling, let's do it in reverse, kinda. We mix it up some. Let's first take the first term. What's the only possible factorization for x squared? X times x, very good. Now, here we get a little off. We don't do outer, but we looked at the last term, but not the last term, the sign of the last term. What is it? Plus. Now, we want 2. How are we going to multiply this by that, your outers, to get a plus here? What does that tell you about the sign? Say again? Okay, they have to be the same sign, right? To get a positive product, you have to multiply the same signs. You look here and see that's got to be minus. So you're absolutely right, it's minus minus. Okay? And then 2 numbers that multiply to be 6 and add to be, okay, 2 and 3. Okay, very good. You can foil it and check it and see if it's right, but it is. Okay? Does everybody understand this? Am I just going over stuff you know really well already, or is this good to review? Is it okay? Okay. All right. So, what do you do now? Okay, here you have a product of 2 entities, right? Equals 0. How can that possibly be? One or the other one's got to be a 0. Can you come up with any 2 numbers you multiply together to give you 0 if one of those numbers isn't 0? No way. No way in the world. So it's got to be one of these zeros. So we say that. X minus 2 equals 0, or x minus 3 equals 0. And what have we just done by factoring and doing this? You've gone from a quadratic equation to a linear equation, and now we know how to solve those, right? How? Add 2 to both sides. Okay, and that gives you x equal 2. And over here, add 3 to both sides. I just ran out of room at the bottom. And that gives you, maybe I can write it here, x equal 3. All right, we have found, and guess what? When you have 2 exponents here, you can have up to 2 solutions, no more. We found 2, we know there's no more. So we found all the x's that make that true, this one true. Let's check them and see if it's right. What's 3 squared? Minus 5 times 3? Negative 15. 9 minus 15 is? Negative 6 plus 6 is? 0. Good. How about 2? 2 squared is? 4. Minus 10? Negative 6 plus 6? 0 again. Yes, we know those are right. I'm sort of anal retentive. I like to have the right answers. Okay. And I want you to do too. Okay. All right. Now, let me say a couple things. I forgot to say it before. I do not like the publisher of this book. I think the Brooks Cole, Cengage, I think they're sort of rip-offs. But I do like the author of this book. Ron Larson does more in his books, I find, than just about any author I've found. And I wanted to point this out. I meant to last time. Notice here at the end of after every example, they have what they call a checkpoint. Okay? Checkpoint is another problem very similar to the one we just did in the example. Okay? Now, I wish we had class time. I'd have y'all doing the checkpoints every time. I've tried it once. I never finished. I mean, it was really slow. I talked too much. Okay? So what I suggest for you is as soon as you leave the classroom and have some free time, whether it's at home or here at school or somewhere else, sit down and go through the checkpoints as well as the homework exercises. Now, here's the deal about the checkpoint. Notice what they say here. Audio, video solution for in both English and Spanish at larsonprecalculus.com. He has a website that has every one of these checkpoints worked out for you. So if you, when you get home or get to the library or another classroom, not in another class, but just you have some free time and want to work on these, go over the ones we just did. That refreshes it, makes it yours, not mine. And then if you have trouble with it, pull out your computer and go to larsonprecalculus.com, and they'll have audio video solutions. Now, not only that, at every homework exercise, when I assign these exercises, look at the top of the page. See calcchat.com for tutorial help and worked out solutions for the odd number exercises. Guess which ones I assign? The odd number exercises, okay? 2 reasons. Number 1, their answers are in the back. So you can work them and then check your answer. If you didn't get it right and can't figure out why you didn't get it right, you could wait until the next class and ask me or see if you can find me your office hours, or you can go to calcchat.com for tutorial help and worked out solutions for the odd number exercises. Why do you need a WebAssign anyway? Okay, you've got all the help you need right here. Good author, good book, okay? Bad publisher, good book. Okay, never mind. Won't go there. All right, that was example 5. Now, here's how I go to a clean page. I would have thought that you could go to pointer options, erase all ink from the slide, nothing happens. So I have to go to screen, and guess what I do? Unwhite the screen. I've never heard of that before. And all that does is go back to the previous slide, and then I have to do screen, white screen again. I love this new Screencast-O-Matic. It's such a handy program. Okay, never mind. Okay. So many steps to do one simple thing. All right, the next thing we're going to do is find values for which f of x equals g of x. Okay? Again, finding values of x such that this is true. So we're finding something like that, x such that that's true. So here's the A problem here. F of x is equal to x squared plus 1. Okay. G of x is equal to, I've lost it, there it is, 3x minus x squared. Okay? Now, they say, find the values of x such that for which f of x equals g of x. So what you reckon we're going to do first? Set them equal to each other. That's what the problem said. So here's your f of x, x squared plus 1, equal, and here's your g of x, 3x minus x squared, and now you solve this for x. What would be your approach? Okay. First, what I look at is what's the maximum exponent? 2. That means not a linear equation, quadratic equation. What is the thing that we're going to try to do with a quadratic? Get everything on one side and 0 on the other side, right? So what we got to do is decide which way we're going to move this stuff. Which way would you like to move? Right or left? You're going to move right. You would say that, wouldn't you? Okay. Okay. Here's what I do. I look at my x squared terms. I got 1 on both sides, so I got to go one way or the other, right? I look for the larger coefficient. Not just larger value, larger, okay? This one's positive, that one's negative. This wins, come this way. That's what I do. You can go the other way, it still works. It's a little more work. I have this theory, have I told you this before, about being good in math? I have this theory, I've never seen anyone prove it, but it's mine, that to be really good at math, I find you have to be just a little bit lazy. Because mathematicians are always trying to find the easiest way to do the problem, okay? Now, any of you qualify? No, you're all hard work. Oh, no, we got some budding mathematicians. Now, the rest of you are hard workers. You can still do it. I'm not going to discourage you. You can still do it, but it might take you a little more, okay? So my trick or suggestion is let's go the other way, okay? How will we get the x minus x squared to the other side? Add x squared. But if you do it to one side, you got to do it to the other side. Now, since you're going this way, we can go on and take care of the other term at the same time if you want to, but if you want to do it in 2 steps, you can, if you like the 2 steps. Okay, okay, what? And how do you do that? Subtract 3x from both sides. Okay, now what have you left with on the left-hand side? 2x squared minus 3x plus 1, and what are you left with on the other side? Say again? 0, a big nothing. Okay. Now, what would you do from here? Factor, good deal. Okay. If it's factorable, it may not be. If it's not factorable, what do we resort to? Quadratic? Formula, very good. Okay. So, let's see if this will factor first. It's a little easier, I think. How do we start? First term, what's the only possible factorization for 2x squared? 2x times x, very good. Now where do we look next? Sign of the last term, what is it? Plus, that means these 2 signs have to be the same. Don't have to be plus, the same. So we look here to see what they need to be. Minus, minus and minus, okay? That and that, okay? And then, let me think, okay, this might take a while. What's the only factorization of 1? 1 times 1. All right, y'all are quick. Okay, 1 times 1. Okay, now, on one that's like this, I want to go back and check and make sure I did it right. So let's FOIL this baby, okay? First is 2x times 2x. 2x times x is 2x squared. That works. Then next is outer, negative 2x, inner, negative x, and then last, plus 1. Let's see what that gives us. 2x squared minus 3x plus 1. Yes, it worked. We did it right. And you also have a smiley face for doing it right. Okay, good for you. Okay. Now, this is not really part of the problem, so you don't have to do that. I just like to make sure that I did it right. So I'm going to take this out of the way here. In fact, I'll even take off the smiley face because I'm not happy anymore. Okay. Now, and this is fun too. All right, to get my pen back. So what do we do next? Set each of them equal to 0 because you have a product of two entities equals 0. One or the other has to be 0. 2x minus 1 equals 0, or x minus 1 equals 0. Okay? The first one, what do we do? It's now a linear equation. Solve for x. How do we do it? Isolate it. Add 1 to both sides. That gives me 2x. That adds a 0 is equal to 1. Divide by 2. And that gives me x equal 1/2. Yay, we love our fractions, don't we? All right. And you can have fractional answers. Okay, next. Add 1 to both sides, and you get x equal 1. All right. Those are our two suggested solutions. Let's see if they work. Fractions are going to make it fun, aren't they? Okay. Let's plug in 1/2. What's 1/2 squared? 1/2 squared. Did I hear 1? I think that's 1/2 plus 1/2. I'm asking for 1/2 times 1/2. 1/4. Okay, that's 1/4 plus 1. How many fourths is 1? 4/4. So 1/4 plus 4/4 is? 1/4 plus 4/4 is? 5/4. Exactly. So this side would be 5/4. Let's see what we got here. 3 times 1/2 is? 3/2, which he's already doing it, 6/4, but we'll do 3/2 to begin with, minus, and what is 1/2 squared? 1/2 squared was 1/4, okay. 3/2 is 6/4, right? Does everybody buy that? 6/4 minus 1/4 is 5/4, yes, same for both. So that one worked. I sure hope one will be easier. Let's see if it is. 1 squared is? Plus 1. Ah, we hit it again. Y'all remembered it from last time, didn't you? Okay, next. 3 times 1 is 3 minus 1 is 2. Yes, 2 is equal to 2. You got it. Very good. Now, again, you had quadratics here, so you don't anticipate having any, you can't have more than 2 answers. You may not have 2, but you can't have more than 2. All right. That was the A part. Let's do the B part. And guess what? We unwhite our screen and then white our screen, or go to a white screen. Okay, this is fun. All right, here's one. F of x is equal to x squared minus 1. Okay, and g of x is equal to minus x squared plus x plus 2. Okay, and we want to find the values for x, all the values for x for which f of x equals g of x. So what will we do? Second, set them equal to each other. X squared minus 1 equal g of x, which is minus x squared plus x plus 2. Did I copy the problem right? Yeah. Okay. Now what? Second? Okay, move it one way or the other. Which way you want to move? Move from the right to the left? Is that what you said? You want to go the other way because there's more terms over there, don't you? Y'all like to work too hard, don't you? We can do it. It'll work. Oh, no, you don't want to do it, huh? You want to go the other way? Okay, actually it is easier. Huh? It's what? Yeah, I would say so too, because this is a smaller value than that. Okay? So let's add x squared to both sides. That gives you a plus x squared. And subtract the x from both sides. And subtract 2 from both sides. And what do you have on the left? Oops. 2x squared minus x minus 3 is equal to 0, 0, 0. That's what we want. Is this not the same one we had before? No. It was close, but not quite. What are we going to do now? Yeah, it's definitely not. We hope it'll factor. We don't know for sure, but we hope it will. Where do we start? 2x squared. What's the only possible factorization? 2x times x. Okay. Then where do we look? Sign of the last term is negative this time. What does that tell you about the two signs? Say again? Opposite signs. So one's going to be plus and one minus, and we don't know which. So here we get to trial and error. Okay? So that's which way you want to put it. Plus minus or minus plus? I don't care. Minus plus. He's looking ahead, isn't he? Okay? Let's see. And then what's the only possible factorization for 3? 1 and 3. Is that how you want to write it? We can do that. 1 and 3. Now, we have two possibilities for error here. That's why it's trial and error. We may have put the signs in the wrong place. We may have put the numbers in the wrong place. If these were both x's here, it wouldn't matter. But with this a 2x and that's an x, yeah, it may matter. So here, I think it's very important to foil it and see if we did it right. So what's 2x times x? 2x squared. This is not part of the problem, it's solving the problem. It's making sure you're solving it right. And then you have plus 6x minus x minus 3. When you combine like terms, you get 2x squared. That's fine. Plus 5x. Wrong. You want a minus x there. So, here's one of my little hints. Okay? If you get the wrong number, change your numbers. If you get the wrong sign, change your signs. Okay? Try it. See if you like it. So, we're going to back off. I wish the erasing was easier here, but I like this program. It's so cheap. I mean, it's so inexpensive or something. All right, we got to change. Okay. Going to leave what I can the same. Okay. All right. Well, I could have left that. Okay. Now let's go back and do my pen again. Okay. So, oh, no, we're going to change our number. Got to erase again. Sorry. The important thing. We're going to change our numbers. Okay? So. Okay. Let's see. Okay. Going to change the numbers. So what we had it before, 1 and 3. Let's try 3 and 1 this time. Okay? And see what we get. Again, we 4. X times x is, 2x times x is 2x squared. That came out okay. Then we had plus 2x minus 3x equal to minus 3. And the minus 3 still works. Good. Okay, and what does this give us? 2x squared minus x minus 3. You got it right. So we're happy with this one. That was just to make sure you factored right. But it's important to do that. I said some of them is not. This one I think is almost crucial to do that. So I'm going to take these out, take this out, because this was just checking to make sure you factored properly. Okay? If you know you did it, you're fine. I mean, you can do it however you want to. Okay. What do we do next? Set each equal to 0 separately. 2x minus 3 equals 0. Or x plus 1 equals 0. Okay? And what does the first one? What are we going to do here? Solve for x. How? Add 3 to both sides. That gives me 2x equal 3. Divide by 2. And we get x equal 3/2. Another beautiful fraction. Okay, we love them. Okay, next. Subtract 1 from both sides, you get x equal minus 1. And by the way, if you can look at this and know that x has to be minus 1, you don't have to do these steps. I do them just as a refresher, reminder what we're doing here. Okay? Okay. I don't write out all my formula. I just look at it, multiply it in my head. If I got it right, I do it. So I'm doing all the steps on the screen. Now I like to check just to make sure. You knew I was going to say that, didn't you? Okay, what is 3/2 squared? A little louder. 3/2 squared? 3 squared? 9 over 2 squared? 4, 9/4. Okay? Minus how many fourths is 1? How many fourths is 1? 4/4. Okay, 9/4 minus 4/4 is 5/4. And by the way, if you need to write these things out, write them out. I'm just doing it a little fast because I'm taking too long. Okay, so this gave us 5/4, right? Let's see what happens when we plug in here. What's 3/2 squared? 9/4. Negate that. Negative 9/4 plus, how many fourths is 3/2? What was last time? Well, how many fourths is 3/2? 6/4. Okay, so you have the negative 9/4 plus 6/4. Yeah, and when you do that, what do you come up with? Negative 3/4, right? Okay, plus 2, and how many fourths is 2? 8/4. Minus 3/4 plus 8/4 is 5/4. Yes, and that's what we had here too. Whew. Those are fractions. I write them out most of the time. Okay, but doing them in your head is a good exercise. Let's plug in a -1 and see what we get. -1 squared is 1. Minus 1 is 0. Oh boy, a big 0 here. Let's see what we get here. What's -1 squared? Negate that. -1 minus 1 would be -2 plus 2 is 0. Yes, we got them both. Okay, so those are our two solutions. Any questions on that? 3/2 and -1. They got it in the book right too. Good for them. Okay, and there are checkpoints after every one of those. Okay, now we can unwhite our screen and go back to where we were. Domain of a function. Remind me, what is the domain of a function? All the possible input values. Quite often your x's, but it don't have to be x's, whatever. So, the domain of a function can be described either explicitly or it can be implied by the expression used to define the function. A little bit of grammar here, huh? Now, explicit, if you think back, remember that piecewise defined function? There your domain was defined explicitly. It was one thing from minus infinity up to 0, and another for all x is less than 0, another one for all x is greater than 0. You've explicitly described the domain, okay? Now when it's implied, here's what we mean. The implied domain is the set of all real numbers for which the expression is defined. So notice, where do we start? Set of all real numbers, unless we find some that you have to exclude, right? That's what we mean by implied. So, for instance, here's a function. F of x is equal to 1 over x squared minus 4. Okay? Now, why would we have to exclude some expressions? What are some things you can never do in algebra? Ever. Can you think of that? Anything you can never do in algebra. Thought you could do everything in algebra, didn't you? There's one thing especially you cannot do. Okay, it has nothing to do with addition, nothing to do with subtraction, nothing to do with multiplication. So it must have to do with division. And what can you never do in division? Divide by 0. You can never, ever, ever, ever divide by 0. Okay? So, when you have a function that has a variable in the denominator, warning, warning, warning. Make sure that denominator, there's no value for that x that would make that denominator 0. So, since you can't divide by 0, find the expression in the denominator, which we have here, and we're going to say exactly what you told me. I forced it out of you, but you said that x squared minus 4 cannot equal 0. That is a 4 there, okay? Do you agree with that? You can't divide by 0, okay? Now, what can you do with that inequality? What's your F word? Factor it, okay? And what do you get? X minus 2 times x plus 2. Yes, y'all got it. That cannot equal to 0. Now, if that was an equal sign there, then we would say that that this or that can't be equal to 0. If that's a can't equal 0, that means that both of them can't be 0. It's not either or, both of those can't be 0. So what does the first one tell you? Yeah, x minus 2 cannot equal 0. So x, add 2 to both sides of the inequality, just like an equation. But now x cannot equal 2, and this one tells you x cannot equal negative 2. And that's an and there, not an or. Okay? So guess what? You just found 2 exceptions. Implied numbers cannot happen. All real numbers except minus 2 and plus 2. Every other real number in the world. So how in the world would we, well, here's how they say it. That has an implied domain consisting of all real numbers x, all real numbers except x cannot equal. I don't like the way they say it, but it's fine. Other than x equal plus or minus 2. I'd rather say x cannot equal plus or minus 2, all other values it can equal. All right, now they are not showing you this now, but they're going to do it later, so I'm going to go on and show it to you now. Those 2 values are excluded from the domain because division by 0 is undefined. You can't do it, so those are excluded. Now, later they will show you 2 ways to express this. They will focus on one, but there's really 2. One way is just saying what I call set notation. Your solution is, or your domain, the domain of this function f, okay, is, and this is really shorthand, the set, remember a domain is a set of all real numbers x, such that, remember the vertical line means such that, x cannot equal, and you can say plus or minus 2 if you want to be really lazy about it, okay? Now, you can also write out, if you want to do, set of all x such that x is any real number except x can't be plus or minus 2. You can write it out any way you want, but that to me is the shorthand of saying x cannot equal plus or minus 2, okay? Now, that's a little extra. I think this is perfectly fine for my purposes, but and the answers in the back may give it in set notation sometime. Now, also, well, okay, never mind. I was going to say something else, but it doesn't apply. Another way to express domains is in what they call interval notation. Now, to do interval notation, I find it helpful to picture the number line, right? That's going to plus or minus infinity, and somewhere in here you got a 0, right? Okay? And you can peg off the numbers, 1, 2, 3, 4, 5, 6, and negative 1, 2, 3, 4, 5. Yeah, all this, okay. Now, that's all real numbers. Remember, that's where we start. We assume all real numbers unless you find some it can't be. So what are the 2 it can't be? Positive 2, so it can't be that one, and it can't be that one. Okay? This is minus 2, this is plus 2. Now, you don't have to draw this, but this is how I think of it. Okay? Now, I think of all the values it can be. That would be every value this way, right? How would you express that as an interval? Okay? Since this is the first time, start off with a parentheses. What's the minimum number out here? Yeah, it's not really a number. It goes to negative infinity. So that's where we begin. Negative infinity up to negative 2. But because it can't include negative 2, we close the parentheses. Okay? If you included -2, you put a bracket. Okay? If you don't include -2, you put a parentheses. Now we're going to union that with all the values in between these 2 points. Now how would you express that? I need a grouping symbol. What do you think that would be? Parentheses. Where are we starting from? -2, going up to +2, parentheses. Okay? That covers all the ones in there, but doesn't cover plus or minus 2. And then we're going to union that with all the ones out here. And where would that begin? Open parentheses, positive, you're right, 2, 2, positive infinity, close parentheses. There's the other way to express. This is called set notation. I call that interval notation. Both of these describe this function. To me, much easier. All real numbers except x can't equal plus or minus 2. That's so much easier to say, okay? So I just say x can't equal plus or minus 2. Put a bar through that, can't equal it, that says it all. Which is basically what that's saying, but it's putting it as a set, that's putting it as an interval. And again, if you included the -2, you would put a square bracket, or a +2, whatever, okay? With infinities, never put a square bracket. That's not really a number, there's always a parentheses around an infinity. Okay, does that make sense? Now, you don't have to draw the number line, but after a while, to me, that gives you some sort of context. And by the way, an open circle means you don't include it, so that would indicate to me parentheses on both sides. Now, if that was a closed circle, then that's going to be a bracket on whichever side you want. Okay? So open circle, parentheses, parentheses. Okay. All right. Another common thing that you cannot do in algebra ever is what? You can't divide by 0, and you can't, and this has nothing to do with addition, subtraction, multiplication, or division, except for the 0 thing. What other operations do we have? You could square, or you could take a square root. Squaring, you can do that to any number. But how about square roots? Again, you cannot take the square root of a negative number, so that's the other common type of an implied domain that is used to avoid even roots. So it's not just square roots. 4th roots, 6th roots, 8th roots, 10th roots, 84th roots, whatever you got, you can't take those of negative numbers. Cube roots, 5th roots, 7th roots, yeah, you can take cube roots, 5th roots, or 87th roots of negative numbers. You can't do the even roots of negative numbers. So this is the one we deal with most, square roots, okay? Alpha of x equals square root of x, okay? When I read this, what immediately comes to my brain? Oh, don't go there. Okay, never mind. What? X cannot be negative. So how do we express that mathematically? If x cannot be negative, that's sort of a negative way to say it. Let's say what x can be. X is greater than or equal to 0. 0 is not negative. So when I see that, I immediately think that. What's inside the radical, as long as it's a square root or a 4th root or even root, cannot be 0. That cannot be negative. Okay. Now, since it does equal 0 in set notation, then I'd say the set of all x's such that x is greater than or equal to 0. That was pretty simple. In interval notation, how would you say that? Okay, again, I'm going to do the number line. You don't have to every time, but just for this time, maybe another time I'll do it. Okay, there's your 0, 1, 2, 3, 4, 5, 6, 7. Okay, negative 1, 2, 3, 4, 5, 6, 7. Okay, where are we talking about? It can be equal to 0 or anything greater than 0, right? So how do we express that as an interval? Bracket 0, comma, positive infinity. One more symbol, huh? Parentheses. Okay? because it's all numbers greater than or equal to, so you're including the zero, put a bracket there. Okay? Here they have it. Okay? Now they finally start showing you the notations. They still don't show the set notation, but a lot of places still use that, so I want you to recognize that. In general, the domain, of course, you always start all real numbers unless there's something that excludes it. And here, all those negative numbers are excluded. In general, the domain of a function excludes the values that would cause division by zero or that would result in the even root of the negative number. Those are the only two we're worrying about now. Hopefully before the end of the term, you'll have one more to worry about. You can't take the logarithm, we aren't there yet, you can't take the logarithm of a negative number, nor can you take the log of 0. So then that would be greater than zero. Not greater than or equal to, greater than. Okay? So logs will come into this as well. We're not there yet. Don't worry about them yet. All right, so here we need to find domains of these functions. What is the domain of that first function? That first function is given in set notation. What is its domain? The domain of f would be, say again, it's going to be a set of numbers. And what would be those numbers? -3, -1, 0, 2, and 4. That's all, folks. That is an explicit domain. Okay? It's a finite, discrete set of numbers of ordered pairs, so it only has those elements in the domain. And that's all, folks. Okay? How about B? What's the domain of that one? You help me. Say again? Okay, where do we usually begin? Assume all real numbers, unless two things. You can't divide by 0, or you can't take the square root of a negative number. I don't see any square roots here, but I do see my variable in a denominator, means division. So what can I say here? This denominator, x plus 5, cannot equal 0. You can't divide by 0. And then solve that inequality, and what do you get? X cannot equal -5. So that to me says it all. I'm fine with that. Back of the book probably won't have that as an answer. It might, but it could have something that says, looks like this. The set of all x is such that x is a real number and x cannot equal -5. That means every other x in the world except that one. Or in interval notation, how would you say that? Where would you begin? Parentheses. What'd you say? -infinity up to -5, parentheses, union that with, parentheses, -5, to all the way to infinity. That's the only number you leave out is -5. To me, that's such a long way to do it, but that's how the book loves to do it. Okay? Now we get into the other one we haven't mentioned yet, but it's reality. The volume of a sphere, they're giving you the equation for it, V is equal to 4/3 pi r cubed. Now, what would be the elements of this domain for that function or equation or formula? What's your input? Say again? The input is your radius. Your output's your volume. Give me a radius, I'll calculate the volume for me using this formula, right? So what's your domain for that function? All real numbers, okay? Give me a real number. Make up one. 5, okay? That you can get the volume there. 5 cubed would be 125. Pi times that, 4/3 of that. Yeah, that's the volume of that cube. Give me another real number. You figured it out. Okay. How about one down here? Negative what? Keep it simple. -2. Oh, I like that number. Okay, no, that's why I flashed it. Okay, now, draw me a sphere of radius -2. What? Draw me a sphere of radius, you said -2, all real numbers in that domain. You can't have a negative radius. And guess what else you can't have? A zero radius. What kind of ball is that? Okay? There's none. Okay? So in this case, there's another type of implied domain if it's a physical constant for which negative numbers make no sense, or maybe positive numbers make no sense, or some other numbers make no sense, you have to exclude this. So in this one, your radii, because that's a physical quantity, the radius is always greater than 0. Okay? You can't have a ball if you don't have a radius greater than 0, right? Okay. So write that in interval notation for me. Parentheses. 0. Okay, yeah, I can't really have an infinite ball either, but let's just imagine the universe is actually comes as close as we can. All right, good deal. All right, how about h? D, it's h of x. Of a negative number. So what are you trying to take the square root over here? No. 4 minus 3x. Everything that's under that radical, what does it have to be? She said it can't be negative, but I can't write a symbol for that. Huh? What's a symbol that I can use? If it can't be negative, it's greater than or equal to 0. That's it. It can be 0. This isn't a ball, okay? So you can't have a 0 there, okay? So now I have to solve that inequality. How do I do that? Subtract what? Subtract 4 from both sides. Very good. This goes away. You have negative 3x is greater than or equal to negative 4. Very good. Now what? Divide by what? Negative 3. Time out, folks. Any warning signs go off? What? Very good. You can add the same thing to both sides of it. This is called a directional inequality, or I call it that. I don't know if the book calls it that. Directional inequality, you can add the same thing to both sides, subtract the same thing from both sides, multiply, okay? Multiply and division, that's where you hit problems. If you multiply both sides or divide both sides by a positive number, you keep that sign exactly the same. If you multiply or divide by a negative number, you flip the direction of that inequality. Okay? That's the rule for directional inequalities. So when you do this, what would that come out being? X is less than or equal to 4/3. Okay? Now, I would think this is a perfectly good answer in set notation. The domain would be the set of all x's such that x is less than or equal to 4/3. Okay? How would you write that in interval notation? Parentheses, I'll buy that. Not for very much, but a little bit, okay? Negative infinity goes all the way down to negative infinity, goes up to 4/3. Because you have the equal sign, it's a bracket. Good deal. Yes? Say again? Okay, if you're dividing by a fraction, that's what you do. Is that what you're meaning? You multiply by the reciprocal. That's what you mean, yeah. That's if that was a fraction. If this had been 4 minus 1/3 x, and you would then divide by 1/3, that's multiplying by 3. Is that what you mean? Okay, now let's just make sure. I like to do this just for sure. pick me a number in this interval. A really easy number in that interval. Okay, 1 is fine. How about even easier? 1 is fine. 1, yeah, 1 or 4/3 either. Let's go with 1, since you like 1. So let's do 4 minus 3 times 1 is 3. 4 minus 3 is 1. Okay. Okay, you go back. Okay, math 1. No, okay, no, okay. 3 times 1 is 3. 4 minus 3 is 1. Yes, you can do that. Okay, I would have chosen 0 because I'm really lazy. He's lazy, but not lazy enough. Okay, if you chose a 0 here, square root of 4. Okay, that fits. Pick something outside of that. 2. Okay, good number 2. Okay, if you did 4 minus 3 times 2 is 6. 4 minus 6 is -2. Can't do that. So that's one really quick way to make sure you've got it right. Pick a number inside. If that works, fine. Pick a number outside. It better not work. Oh, let me give you some homework exercises. I don't want you all weekend with no homework exercises. All right. Do either 5 or 7. Do number 9. Any of the odds 11 through 19. Any of the odds 21 through 31. 33 or 35. Any of the odds 37 to 43. 45 or 47, and then start doing any of the odds 49 through 59. I think you can do most of them. Okay. 44 and 45. 5 or 7, or both if you choose. Do number 9. Any of the odds 11 through 19. 11 through 19. Any of the odds 21 through 31. 33 or 35, any of the odds 37 to 43, 45 or 47, any of the odds 49 through 59. We'll stop there. If some of those last ones give you problems, we'll do a few more of those. Yes, ma'am. I'm sorry. Yeah. Oh, I meant to say that earlier. Shucks, I forgot. Yes, I've gotten the earlier recordings are now on Blackboard under content, and my syllabus is there, the research paper instructions there, my locator card's there, all the PowerPoints are there, some of the websites are there, and then the very last thing there says Math 112 YouTube videos. Click on that and you'll see all the ones for this course. I'm sorry?
Remember when you said we did need the code, but there was somewhere in here where we could go to watch the audio.
Right.
Where is that?
Okay.
Is that only that book or?
Have you got the same author? Who have you got? Who's the? Oh, Lawrence. Yeah. I'm guessing, but I don't know. That's just an earlier edition.
No, it's an older edition.
Yeah, that's what I mean. Okay. Let's see if he had it there. No, he didn't have it there, and he didn't have the checkpoints, okay? So, yeah, but you can still go to those websites. It's larsonprecalculus.com, and it's calccheck.com, okay? Okay?
You said this
is she has an older edition. They're not in that one, but they're in this one. Let me turn this light off, okay. That's where you go for the other examples like your thing. Where did you look at? That one. That's the one where your checkpoints are, and right up here, calccheck.com. That's where your homework exercises are. And see, that's not yours. So if you want to take a picture of that too, or calccheck.com.
Will I be fine with this?
Yeah, I bet you very little has changed except they've added these two things. There will be a few different examples. Calccheck.com, that's for the homework exercises.
Okay.
Okay?
Okay.
Good deal. Now, I bet
now,
you...
I have a question.
Yes.
Now, on the syllabus, it says we're going over chapter 1.
Yeah. 2.
I believe 2,
Yeah,
3,
3.
and 7.
Yes.
That's it.
Right.
Correct? And the sections are on there. Those are the sections that we're going over.
Right, yeah.
Okay.
Now, if we don't get to 7, I'm not going to sweat too much because it's stuff you've had before. Yeah, so we'll get as far as we can. This is the basic stuff. This is the most important. I want to make sure everybody gets this well.
Okay. But for sure,
We
1,
won't
2,
go
and
any
3.
more than that. Hopefully, yeah, we'll get through 3. We may not get all the way through 3, but we're going to go as far as we can. I talk too fast and too slow, but if there are questions, big classes will have more questions.
Do you normally always get done with chapter 3, or you
Not always, okay.
Kinda stuff.
Sometimes some 4 in
Because I
3.
know there's a lot of sections.
There
in
are tons of sections. And I try to skip the ones I think are not as crucial, you know.
Okay. I was asking because on some of the problems that you worked today, it was like I got it.
Yeah.
But on some of them, it was just like what? So I wanted to make sure that if I studied something ahead before, I wanted to study what you were going to teach in the class.
Yeah.
Instead of
And for instance, everything from 1.4 to 1.9. I think there's a 1.10. We're not going to do that.
1.4
we did-
through 1.9.
Yeah, and we started at 1.4 and we're going through 1.9. Then we'll go to chapter 2. We'll do most of 2. There'll be a few places I say we'll just do a slideshow of this and just go on, you know. But the main thing is
No, I know you said the most important one is chapter 1.
chapter
right?
1.
Will the other one be kind of like 100, or it'll be different? The rest of it.
Okay, what's that?
The rest, like chapter after chapter 1,
Yeah.
will it be kind of like 100?
Kind of like 100. No,
It will
1
be different.
1 through 1.3 are like 100. You know, that's stuff you had in Math 100. Now, you probably touched on functions in 100, but probably didn't get really all that far. Should have done domain and range, but if you didn't, you know, yeah. Okay. Chapter 2 is still talking about functions, but it's familiar stuff. Quadratics, and then higher order, and then we'll do rationals, okay? Functions, which you did rational expressions in Math 100, and you did quadratic
I know
equations. So now we're just doing them as functions. So we'll do a little bit more. Mostly the graphing is going to be stuff you didn't do in 100 on, say, rational expressions. I don't think we ever graphed rational expressions in 100, but we'll be graphing them here. So there'll be, this builds a lot on 100, just takes it a little further, deeper. Yeah.
Okay, one last question.
Okay.
For our quizzes and our tests,
Mm-hmm.
the stuff you gave us to work on the problems,
Right.
that's how it would
Those
be.
are,
the
the
test
question would
would
be very similar. It won't be the same, but they'll
Oh,
be
yeah,
similar.
no, but you work it the same way.
Yeah,
That's what I'm saying.
basically,
Okay, cool.
yeah.
Thank you so much.
Uh-huh, glad to. And we recorded all that.